How do you find sine, cosine, and tangent if you don't know all three sides of the triangle? That's what we'll be talking about today. So we'll start by identifying our angle theta and labeling our sides. So across from theta, we have the opposite side of 6. Next to theta, we have our adjacent side of 8. And of course, across from the 90 degrees, we have our longest side, the hypotenuse. Now notice we know the opposite and adjacent sides, but we don't know what the hypotenuse is. This is going to be a problem for us because to find sine and cosine, you need the hypotenuse. So what do? It's simple. Just use the Pythagorean theorem. Remember a squared plus b squared equals c squared? We use the Pythagorean theorem to find the missing side of a right triangle as long as we know the other two sides. The thing to remember is that c is always the hypotenuse. So we'll label our sides A, B, and C, and we just want to make sure that we label the hypotenuse as C. So the A and B, it doesn't matter which one you label as which, they're interchangeable. Okay, so we have A is 6 here, so we've got 6 squared. B, we said, is 8, so plus 8 squared equals, and then there's that C, the side we don't know, so equals C squared. Now we'll just solve using our algebra skills. So 6 squared is really just 6 times 6, which is 36. 8 squared is 8 times 8, which is 64. And then we'll keep that C squared on the right-hand side, so we still have something to solve for. All right, so 36 plus 64 equals 100. So we have 100 equals C squared. Now, C is almost by itself, but to fully get it by itself, we have to undo the squared by doing the opposite and square root both sides. So the square root will cancel out the C squared and leave us with just C all by itself. That's what we want. So the square root of 100 on the other side is 10. So C equals 10. All right, so now we know all three sides of the triangle. So we're ready to write our sine and cosine fractions. So going back, we know sine is the opposite side over the hypotenuse. So we know opposite side is 6. Hypotenuse, we just found that. Now we know it's 10. So 6 over 10, and that simplifies to 3 over 5. For cosine, we've got our adjacent side of 8. And again, our hypotenuse is 10, so 8 over 10, and that also simplifies this time to 4 over 5. So there we have it, sine and cosine. One more example with tangent. So in this case, once again, we'll identify our angle, label our sides. So through the triangle, there's our opposite side. We've got along theta, we've got our adjacent side. And here the hypotenuse is 41. Notice the hypotenuse is that bottom side of the triangle. It can be hard to notice that because it doesn't look as slanty as it usually does in some of these other problems. But again, the hypotenuse is always across from the 90 degrees. Okay, so we've got our sides labeled. We don't know the opposite side, so that's our cue to use the Pythagorean theorem. So we have a squared plus b squared equals c squared once again. And this time we're plugging in 41 for c because 41 is the hypotenuse. Again, the hypotenuse is always c. The other two sides can be a and b. Doesn't matter which one's which. So we have a is 40, so 40 squared. B we don't know, so I'll just keep it as b squared equals, and c we said was 41, so 41 squared. Now our goal is to get b squared by itself. So first we'll square the 40. So 40 times 40 is 1600 plus b squared, and then again 41 squared is 1681. Now we'll subtract 1600 on both sides because again, we want to get that b squared by itself. So 1681 minus 1600 equals just 81. Now we'll square root both sides to get b completely by itself, and the square root of 81 is 9. So now we know b is 9. So that tells us that our opposite side is 9. So now we're ready to write tangent. So remember, tangent is opposite over adjacent. So we can say tangent of theta is our opposite side of 9 over our adjacent side of 40, and we're done.